Welcome back to 6-Minute Statistics. In this video, I'm going to look at a bunch of introductory probability rules. You know the ones that are driving you crazy and making you search YouTube for answers. Well, as always, 6-Minute Statistics is going to offer some help. Let's go.
Give me 6 minutes and I'll teach you something new. Now, let's get to work.
Mark here from 6-Minute Statistics, and I want to start by putting your mind at ease. Nobody likes these formulas, not even me. You know my motto, keep it simple, student. These probability formulas definitely don't abide by that motto. The good news is in my next video, I'm going to show you how sometimes we can do probabilities without these formulas, without these rules. But for now, let me try to break them down for you and show you how they work. All right, let's first take a look at some of the more common introductory probability rules. You see them on the screen next to me. First thing to note is that the A and the B in these formulas refer to events or outcomes from an experiment that we're interested in. The additive rule helps solve the or probabilities that we might be interested in. The multiplicative rule is useful for the and probabilities. The or and the and probabilities were discussed in a prior video. The conditional probability rule is just another way of writing the multiplicative rule depending on what it is you're trying to find. And lastly, the complement rule uses a symbol where I use the A with the C complement or the superscripted C. That's one way of writing the complement of event A. Another way is to put an A with a bar over it. You may see that in place of the A with the C. Let's take a look at an example so we can see these rules in action. Free throws in basketball are shots that are awarded to players after they've been fouled. They are the only shot in basketball that's uncontested, meaning that the player can take his or her time and take the shot when they are absolutely ready. Suppose a player has been fouled and they've been awarded 2 free throw shots. We also know that this particular player has a 70% chance of making their first shot. Now, depending on whether they make or miss their first shot, that affects the probability of the second shot. If they make the first shot, let's say the probability to make the second shot increases to 80%, and if they miss the first shot, maybe it decreases to 60%. All right, I know that's a bunch of information. Let's look at it this way. Let's define 2 events. Let's say event A is the player makes the first shot, and event B is they make the second shot. What I just told you is the probability that they make their first shot, or the probability of A, is 70% or 0.7. We don't know yet the probability of making the second shot because the information I gave you are what were called conditional probabilities. The probability they make the second shot given that they made the first shot was 80%. The probability to make the second shot given that they missed is 60%. Those are shown here. With 2 free throws, there are 4 possible outcomes. The player may make both. They may miss both. They may make the first and miss the second, or flip it around, they may miss the first and make the second. What I want to do is show you how to use these rules to find the probability of these outcomes, and then some more. Let's first take a look at the probability they make both shots. To find this, we're going to use the multiplicative rule of probability. The probability of A and B, making the first and making the second, can be found using the probability of A, which we know, times the probability of B, given that A has occurred. Notice the conditional line, that given A. Well, that probability is 0.7 times, there's an 80% chance of making the second after they made the first, so 0.7 times 0.8 or 0.56. We'd say there's a 56% chance both shots are made. How about the probability that they make the second after missing the first? This would be the probability of A complement and B. And we're going to find that by the probability of A complement times the probability of B given at A complement. Well, the B given A complement we already know. We know there's a 60% chance they make the second shot after missing the first. What's the probability of missing the first? It's the complement of making the first. So it's going to be 0.3 times 0.6 or 0.18. Putting these 2 probabilities together, the probability they make the second after making the first and the probability to make the second after missing the first, that's how we're going to find the probability they make the second shot. The probability of B is the 0.56 plus the 0.18 or 0.74. There's a 74% chance this player makes their second shot. The other 2 probabilities where the second shot are missed are shown here. You're going to notice lots of complements from the original information are being used to find these probabilities. All right, now suppose it's the end of the game and the player's fouled, and they need to make at least one shot to win the game. What's the chance they succeed, or what's the probability to succeed? Well, in order to succeed, they have to make either the first or the second or both. And that sounds a lot like the additive rule of probability. So I'm going to figure out the probability of making the first or making the second. We're going to find that finding the probability to make the first plus the probability to make the second, that's B, minus the probability of both. And so we plug those numbers in that we already know now, and it's 0.7 plus 0.74 minus a 0.56. There's an 88% chance that that player is going to win the game. All right, that was a lot of information. How about some good news? Sometimes these rules, the additive and the multiplicative rule, can be simplified. In an earlier video, I explained mutually exclusive and independent events. We said mutually exclusive outcomes were events that did not happen at the same time. In other words, the intersection between them is zero. The probability of A and B would be zero. And so if you have mutually exclusive outcomes, the additive rule simplifies to where we can just sum the probability of A plus the probability of B. No intersection takes place, so we can ignore that part of the rule. Likewise, independent events, we found that knowing that A has occurred or not doesn't affect the probability of B occurring. So there are no conditional probabilities. B given A or B given A complement, it doesn't matter because A doesn't affect B. So the multiplicative law can be simplified to where we just multiply the probabilities of A times the probability of B. Sometimes people present these two rules as additional probability rules. I don't like thinking of it that way. They're just special cases of the additive and the multiplicative rule that we already know. All right, that's about it for the introductory probability rules, and honestly, that's probably enough. What you should do now is go ahead and practice some of these rules. And now, my friends, it's time for you to get to work. So long.